get this started up for us. Okay, so sections 1.4 and 1.5. These are sources of errors in sampling and experimental design are the two sections that we are going to look at today. Okay, the types of errors that we want to talk about. First are non-sampling errors, and these are the two broad categories of errors. Non-sampling errors are errors that result from the survey process. They may be due to non-response, inaccurate responses, poorly worded questions, or bias in the selection of individuals. The other types of errors are sampling errors, and these are errors that result from using the sampling to estimate information about a population, and it occurs because a sample might give some incomplete information about the population. Now let's talk about the types of non-sampling errors. These may be misrepresented answers, which are when somebody answers a survey result, they may either misrepresent the facts or be out and out lies. You might have data entry errors. You might have errors in the questionnaire design, okay? And a good design is really going to be critical to minimizing the amount of the non-sampling error with regard to this. Two types of questions. You can have open-ended questions or closed-ended questions. Open-ended questions are like short answer questions, where what you want to do with these is make sure that they know that the questions are worded such that the responses you're going to get from the participants are similar. The other type is closed-ended questions. These are like your multiple choice answers, true, false, yes, no, that kind of thing. Wording of the questions. Questions must be asked in a balanced form to avoid error. Yes, no questions are something that aren't balanced because you might have an inherent bias with the way the question's worded. For example, a local issue is, should the water in Wichita be fluoridated? Yes or no. If you word the question in this way, it's kind of biased that it should be. Okay, you could also word the question, should we avoid fluoridating the water in Wichita? Which would be a negatively balanced question. So you can see how these types of question balancing issues are bad. So what you want to do is give your participants two choices that are equal in nature. So an example would be, do you favor or oppose water fluoridation in Wichita? Okay. Questions should also be very specific, not vague. So vague would be, how much do you study? This doesn't really tell you what units you want. Are you talking weeks, months, years, what course, all of them together? The participants aren't going to know how to answer this, and you're going to get answers that aren't specific enough for you to evaluate. So ask your participants exactly what you want to know. How many hours per week do you study for this class? Would be an example of a specific question. Order of questions, the words and responses. Participants are often likely to choose the early responses in a list of choices rather than later ones. And so what researchers often do is they rotate the order of the words in questions in different questions so that the full picture can be seen. So if you feel like you're being asked the same question with different wording all throughout the survey, you are. The reason is to minimize error. They want to make sure that you don't just pick the first response versus the one that you really mean. Okay, now let's talk about the design of experiments. A designed experiment is a controlled study conducted to determine the effect that varying one or more explanatory variables has on a response variable. Okay, so our explanatory variables are the things that explain why the treatment works or doesn't work on the response variable, which is what we're really interested in studying. Okay, so the key to a good design of an experiment is controlling, manipulating, randomizing, and replicating all the treatments that you do and the variables of interest. Okay. A treatment is the actual change that you're making to your response variable. So for instance, I want to test whether a specific method of teaching is working better than another method of teaching. So I would have a normal method of teaching and then a treatment method of teaching that would be different in some way from my normal method. Another term is an experimental unit. This is the person, object, or some other well-defined item to which a treatment is being applied. Now, for the most part, we talk about medical research and things like this, but it also could be a piece of steel. You know, you want to apply a treatment to a piece of steel to see if it works better than some other method of doing things. So it does not have to be a person, it can be an object, it can be just something that you know what it is. But it is called a subject if it is a person. Now the goal of an experiment is to determine the effect of various treatments on your response variable. And you're going to want to organize these things in a method that's going to make the data that you collect usable for you. Let's talk about several types of experiments. Double blind. This is where neither the experimental unit nor the researcher knows what treatment is being administered to the experimental unit and whether that treatment is a placebo, which is kind of like a fake treatment, or an actual treatment. A placebo would be like an innocuous medicine or a treatment of some sort that's meant to replicate the real thing, but is not the real thing. Okay, it's completely innocuous. So, like instead of giving somebody a treatment that is really a medicine that's being experimented with, you might give somebody a sugar pill. Okay, steps of experimental design. First, you want to identify the problem to be solved. What are you looking to solve? What is your issue that you're having? What are you testing? Then you want to determine the factors in the surrounding area that are going to affect your response variable. Okay? These factors can be any number of things. You're just going to really have to look and see what are the things involved with your particular design. Then you want to decide how many experimental units you're going to have. And this is going to be a long process where you look at really what's the danger to the people, how many samples do you need to make an adequate decision, that kind of a thing. And we'll look at more of how to choose that later. Then you want to determine the level of each factor. Now the factors that you looked at as affecting the response variable is what we're talking about here. So can we control that factor? Can we fix some levels or allow them within a certain range to keep things from varying so much that you have additional factors from not having controlled certain factors? Okay, because everything has a cause and effect. Next, you want to manipulate. You could either manipulate them or set them at predetermined levels, and these levels themselves would constitute a treatment. Another way to determine the level of each factor is to completely randomize everything, and assuming that this is going to average out the effects of your uncontrolled factors on your variables. You're going to next conduct the experiment. You're going to try to randomly assign treatment to your experimental units, and try to replicate or use as many experimental units as you can safely, and within reason of cost. So cost will drive a lot of this as well. How much money do you have to conduct this experiment will determine a lot of times how big your experiment can be. And then you want to collect and process your data. Finally, you're going to test your claim. And this is where we take that data that we collected and processed during the experiment, and we use our inferential statistics on it to test and see whether our hypothesis holds or not. Let's talk about the types of experimental design. It can be completely randomized, where experimental units are randomly assigned to a treatment. You could have matched pairs, which are experimental units that are paired up somehow in a related way. So you could have twins, sisters, husband, wife, same geographical area. Anyways, there's only 2 levels of treatment in the matched pairs design. Finally, you could have a randomized block design, and this is grouping similar, and a synonym for that is homogeneous, experimental units together, and then randomizing the experimental units within each group to a treatment. So you have a group of people, and within that you'll have a control and experimental units within the group. And that is it for today.